Utility data analysis and calculating energy use intensity. Utility bills are a useful tool to gauge a building's energy use and estimate the efficiency of the building. In addition, utility data can give the building professional a means to evaluate potential energy savings. The utility bills are from the utility that distributes the utility to the customer. The utility bills contain a variety of information in addition to the amount that's owed by the customer to the utility. This includes the energy consumption, the rate information, the billing period, and other information such as taxes and surcharges. Utility customers pay different per unit costs. These costs can vary significantly depending on the time of day, the location, the type of facility, whether it is commercial or residential, among other factors. In analyzing a building's performance, it is useful to use utility bills over a period of time, typically for a few years. This provides the analyst with sufficient information to establish the energy use intensity of the facility, referred to as the EUI. In this learning module, we will gather information for a building, which is a residence, based on annual utility data. And using the information from the data, we will calculate the energy use intensity, referred to as the EUI, for that residence using the standard industry metric, which is kBTU per square foot per year. We will use Excel as a tool to document the analysis and make an assessment on the efficiency of the residence based on a sample rating system. And finally, you will develop a professional document in memo format to present your work. For purposes of this study module, we will limit our analysis to electrical and natural gas use, since this comprises about 90% of the energy use in buildings in the United States. Other sources are available, of course, such as propane, wood, and coal, but these are not common, and so we won't cover these utilities in this analysis here. Electrical energy is measured in kilowatt hours. Natural gas energy is measured in cubic feet, where 100 cubic feet is approximately equal to a therm. A therm is 100,000 BTUs. In comparing a building energy use with different fuel types, it becomes necessary to find a common denominator or unit of measure. The primary unit in our industry is the British thermal unit, or BTU. By definition, one BTU is the energy needed to raise the temperature of 1 pound of water by 1 degree Fahrenheit. We can convert from units of energy from the utility billing as follows. 1 kilowatt hour is the same as 3412 BTUs. Also, 1 therm is the same as 100,000 BTUs. A kBTU is 1,000 BTUs. You may run across a unit called the MMBTU, and that's 1,000,000 BTUs. And as you can see, these units are what are common in our industry. A little bit notice about demand, kW. We won't talk about that much in this module, but facilities do have a peak load on their electrical system, and that's called the demand. But our analysis today will be limited to the energy use of electricity, which is kilowatt hours. Calculating energy intensity or energy utilization index. The energy intensity or energy utilization index is referred to as the EUI. Basically, it is the building's energy consumption, the total energy consumption, divided by the floor area. It is important when working with different fuel types, for example, electricity and natural gas, in a single building, that we convert the fuel uses into that common unit for analysis. And the unit used in the industry is the kBTU. Recall that a kBTU is the same as 1,000 BTUs. So in analyzing a building's energy use, we look at the utility data for all the fuels, convert the data to kBTU, and divide by the conditioned floor area. The conditioned floor area means that we do not include spaces such as courtyards, unheated attics, or basements, etc. And the result that we find is the EUI in kBTU per square foot per year. On this slide, I show you the simple way of how to do this. The EUI is the kBTU per square foot per year. For electricity, we take the kilowatt hours. 1 kilowatt hour is equal to 3.412 kBTU. So we multiply the electrical use in kilowatt hours by this number, 3.412, to get the electric use in kBTU. For natural gas, which is built in therms, 1 therm is equal to 100 kBTUs. So we simply have to take the multiple gas use in therms by 100 to get gas use in kBTU. So your first step will be to gather all of the utility data for your facility or your building for at least 1 full year. For this assignment, we've already done that for you. Here is the electrical bill for this assignment for 1 month. Okay, so what we have here is we have the electrical bill for 1 month for our sample residents that we're going to do this analysis on. And the first page here is a summary of what the client owes to Southern California Edison. This amount due is not what we're interested in because that apparently includes some late fees and some other things. But what we want to do is we want to look a little deeper into this and analyze what is important to us. And that what's important to us in this application is that we want to look at the billing period and we want to look at how much they paid in that period. So this account billing period goes from December 20th to January 21st. And there's 2 accounts on here with 2 charges. And this charge that's going to go into our data for our analysis is this 537.67, which is shown up on this page. So that's what we're going to use for the cost for this electrical bill for the first month of this analysis. Now, the next thing we want to know is how much kilowatt hours did they use in this period? And that shows up on this summary sheet here. And as you can see, the cost varies depending on the time of day. They have mid-peak, off-peak, and super off-peak. And each one of those time periods has a different cost per kilowatt hour. As you can see from super off-peak, that's the cheapest. That's at 27 cents per kilowatt hour. And during the mid-peak, this client is paying about 35 cents per kilowatt hour. And in this table, it shows where your energy use fell in those time periods in this billing period and how much each one of those cost. And as you can see, it has this total of 337.27. In addition to that, there's some more information here that shows how their electric use has varied over time. And then some more details of charges. And as you can see, electrical bills are very complicated. And there's all different kinds of surcharges and other things that get associated to that. But as you can see, it falls down to this 337.27. That's for that first account. And then the second one is what we need to do is this other Clean Power Alliance, this TOU-D-5. We're going to add that in to our cost, this 204.40. So that's how we got the total cost for this month for this building, for this billing period. Now, what is the kilowatt hours that we're going to use? That's on this sheet right here. We're going to input into our data for the month of January that this facility used 1,269 kilowatt hours. So that's our data that we're going to use. So in summary, we have the total kilowatt hours, 1,269 kilowatt hours, and the total cost shows up right here as the 537.67. Again, electrical bills, they just have all sorts of billing rates depending on time of day and all sorts of stuff and all sorts of charges and everything. So we're going to keep it simple and include in our cost these two service accounts, and our total kilowatt hours is going to show up on this sheet as the sum in this table, the 1,269 kilowatt hours. So I'm going to end the recording there because it's gone over 10 minutes and give you a chance to digest that. And then the next recording, part 2, we'll look at the natural gas bills and then how to put this all together into your assignment and what's required there.